Hello, and welcome to day 26 of learning ML from chatgpt. So let's get started. So in yesterday's video, we looked at distributing our workload, there's two ways we could have done it, distributing the model and also distributing the data. Data parallelism and model parallelism, which should make it much faster, as we saw with the training on the MNIST dataset, which took way longer just doing on a single GPU. Okay, so now let's answer for day 26 lesson. Let's see what we've got. Okay, BERT and GPT. Oh, advanced natural language processing. Let's go. Will we create a large language model? So please give me day 26. This lesson. Okay, let's see what it gives us. If it can even, I don't know, it's such a large file that now, yeah, I don't know. Okay, day 26, advanced NLP. What? Is it not GPT 4.0? I'll try again. Okay, this should redo it. Whilst we're just waiting for that. Oh, yeah, okay, it's done now. So day 26, advanced NLP, BERT and GPT. BERT, bidirectional encoder representations from transformers. Okay, so BERT is a transformer-based model. So transformer, remember, is when you encode stuff and decode stuff, and like for instance with natural language, we encode our natural language into, I can't remember the exact term for it. It was intermediate state, and then intermediate state then to like generated output. So yeah, we use encoding and decoding. This is transforming the data, and then so it's bidirectional. So bidirectional means it can go both ways. Like it has context from both before and after in the sentence, for example. So BERT is a transformer-based model designed for a variety of NLP tasks such as text classification, question answering, and name entity recognition. It is pre-trained on massive amounts of text in a bidirectional manner, both left to right and right to left, to understand the context better. Yeah, okay. BERT can be fine-tuned on specific NLP tasks by adding small task-specific layer on top of the pre-trained model. GPT. So this is like ChatGPT here, which is ChatGPT 4.0. Okay, generative pre-trained transformer. GPT is another transformer-based model, but unlike BERT, GPT is unidirectional. It generates text by predicting the next word in the sequence. GPT is used for tasks like generation, summarization, and conversational AI. GPT models, e.g., GPT-3, can generate coherent and contextually relevant text, making them powerful for many generation-based tasks. So, yeah, this is the difference is BERT multidirectional and GPT unidirectional. They're used for text classification, question answering, and named entity recognition, where GPT is more for generational like text. For example, fine-tuning BERT for text classification. Here's how you can fine-tune a BERT model for text classification. So BERT models are already trained models. We can fine-tune them. We can add like an extra last layer that so it's fine-tuned to our specific need for the model. Okay, so let's see what we're doing here. So we're importing transformers. No, from transformers, import the BERT tokenizer, and I assume TF BERT is a TensorFlow BERT for sequence classification. Okay, tokenizer equals BERT tokenizer dot from pre-trained BERT base uncased. Model equals transfer BERT for sequential classification from pre-trained, BERT case and case. And we're having two labels. I'm going to ask it to explain this. Please explain this code line by line. Oh. It doesn't seem to work either. Okay, now we've got it detailed. I'm going to delete this. Okay. So here's a detailed line-by-line explanation of the code we when we fine-tune a BERT model for text classification. So transformers are a popular library for NLP like BERT, GPT, etc. Developed by Hugging Face. So if you didn't know already, Hugging Face has loads of, I think they're all open source, like AI models and ML models. I think it's also got a chatgpt competitor. But I don't know for certain. I've been on its website a couple times. So BERT tokenizer. This is the tokenizer specifically designed for BERT. Tokenizers convert raw text into a numerical format that the model can understand, i.e. tokens or token IDs. Okay. BERT tokenizer. So this loads a BERT model pre-trained for sequence classification, like sentiment analysis or spam detection in TensorFlow. So we did do sentiment analysis before. I can't remember which model we used. I think it was maybe being a recurrent neural network. I'll have to consult it later. So TensorFlow machine learning library, yep, and the Adam optimizer. The optimizer used to update the model's weights during training. It is adaptive and works well for large models like BERT. Load BERT tokenizer model for sequence classification. So tokenizer equals BERT tokenizer dot from pre-trained BERT case and case. This loads a pre-trained BERT tokenizer, BERT case and case. BERT base uncased is a 12-layer base model. Uncased meaning that it doesn't distinguish between lowercase and uppercase letters. Okay, so yeah, it just makes it much easier for the model. It allows you to turn raw text into the token IDs needed for the model. Okay, and then model equals TF BERT for sequence classification. If you remember, TF BERT from sequence classification is the pre-trained BERT model. I think 12 layers. Oh no, that was BERT base uncased. From pre-trained, this loads a pre-trained BERT model, BERT base and case for sequence classification tasks. Num labels 2 means the model is designed to classify into two categories, binary classification, e.g. positive or negative sentiment. Okay, now to the next one. Tokenize the input text. Okay, let's see what we're doing here. So input IDs, attention masks, we're setting them both to empty arrays. Then we're going through each text in text, and we're going to encode each text. We're going to just add these extra parameters, and then we can append our encoded data, input IDs, and then direction masks. Okay, and then input IDs concat input IDs x0. So here we're just changing the shape basically, I think. And then TF converted tensor labels. So this function prepares tokenizers raw text so that it can be used as input to the BERT model. Text labels the raw input text and their corresponding labels, i.e. class targets for training. Input IDs, attention mass, these are lists where we store the numerical token IDs, input IDs, and attention mass for each sentence. Attention mass tell the model which tokens to pay attention to and which tokens are padding. So 1 is pay attention to, 0 is just padding. Then loop for each sentence, encode plus. Converts the input into token IDs, add special tokens like CLS at the start and set at the end that BERT uses for classification. Truncates the input text if it exceeds the max length and pads if it's shorter. returns a tension mask tensor that indicates which parts of the input are actual tokens, which are added padding. Input IDs are append, say the token IDs for the current sequence, attention IDs, save the attention mask for the current sentence. Yeah, so the attention mask just indicates which of these input IDs are important, like are real. Okay, and then return block that concatenates all token IDs and attention mask in a single tensor using tf.concat. Yeah, okay. And returns them as a dictionary. Converts the labels into a TensorFlow tensor. Example data. Text. I love this movie. This film is terrible. Labels. Text 2 example sentences. And this film was terrible. To demonstrate positive and negative sentiment. Labels. These are the ground truth for the labels for the 2 sentences. 1 for positive sentiment, 0 for negative. Okay, tokenize and prepare the data. So yeah, here we're just going to tokenize the data for X train and Y train. This function tokenizes the input text and converts them into a format suitable for the BERT model. X train and converts the labels Y train into tensors. Compile the BERT model. So here we're going to use Adam optimizer. Learning rate of this and epsilon of. Okay, ChatGPT has obviously picked these for a reason as the. So I'll see. Optimize equals Adam learning rate 2e minus 5 epsilon 1e minus 5 creates an Adam learning rate which is small and required for BERT fine tuning BERT and epsilon to improve numerical stability. Okay. Model.compile compiles the model by specifying optimizer Adam for adjusting models weights during training, loss, sparse categorical cross entropy, as we've used so many times now, is used for binary and multi-class classification, which where the labels are integers. Metrics, accuracy, tracks the percentage of correct predictions. And I suppose, like, if you have text, you could just convert them all to integers, and then, yeah, so then much easier. So you could probably use space categorical cross entropy. But I'm not sure. Probably though, because yeah, you could just turn them into the ASCII values or just like arrange 1 through 26, and that would. But then you'd have to, for instance, on a single digit, you'd have to do 01, 02, so like the same like number of digits as 25 or so. So model.fit trains BERT model and tokenized training data X train and Y train. Epoch 3, number of times the model sees the entire training data set during training. Batch size 8, the number of samples the model processes before updating its weights. So the lower the batch size of actually, no, I think it'd be, yeah, the lower the batch size, surely, the better it would be. Now, save the model.save pre-train, fine-tune BERT. Model.save pre-train saves the fine-tune BERT model so it can be loaded later without retraining. This saves the model weights and architecture in the directory fine-tune BERT. Okay, now I'm just going to go back to the code and we'll read through it because we just, so the tokenizer, this converts let's see, it converts them into like the token 12. It allows you to token IDs, yeah, for the model. Okay, so this turns the token IDs no, the text into token IDs, then the model, this is a pre-trained BERT model and we're training on our no, we're not, sorry, it's just pre-trained BERT model and we're using BERT based on case. So this is where the BERT model doesn't care about whether it's uppercase or lowercase, and then num labels too, because this is going to be for binary classification. So tokenizing data, we have input IDs and attention masks. Input IDs are just all the input IDs, and attention masks are basically the ones you want to pay attention to. So which ones are actual token IDs and which ones are just padding. So we're going for each text and we're getting the encoded data using tokenizer.encode plus. So passing the text and all of these special inputs. So input IDs.append. So here we're just converting it into a single tensor and returning a dictionary. Yep. and then we're converting it to a tensor here. Text. I love this movie. This film was terrible. So positive sentiment, negative sentiment, X train, Y train, tokenized data. Okay, then we add optimizer, and then we're going to compile it using sparse categorical cross entropy. Then we can fit the model, epochs, and batch size, and then we can finally save the model. So we're just going to save the architecture, and so we don't have to redo it all again. But this may take a while. This is kind of where we need the distributed workload across GPUs. But as it's a pre-trained model, I'm not sure we can do that as, just the architecture won't, Because if we did what we did yesterday, I don't think it would do anything. Maybe it would just split some things up for, no, we don't even have any, no, I don't think it would do anything. Okay, this may take a while. As we're importing the BERT tokenizer and the actual pre-trained model. I'm still not done that. 32 seconds already elapsed. Yeah. Oh, no, we are traveling through, so we're just turning text into token IDs. Now we're getting the pre-trained model. This may take a bit of time, though. Okay. But based on case, which we're using for both. Already got an error. Train the model. Some weights or buffers of the TF 2.0 model were not initialized from the PyTorch model, newly initialized. You should probably train this model in downstream tasks to be able to use it for your predictions. By error. Could not interpret optimizer identifier. Oh, okay. Okay, I'm just going to paste this to ChatGPT and see if it can regenerate. But it doesn't seem to be accepting text. There's a problem. So then I may just have to leave the lesson here as I can't progress forward. But we got the key concepts of it, the BERT and the token IDs. So when we process it, we have the token IDs and we have the attention mask, and then we're going to train it on the BERT base uncased, and we can just run through the code. And so we're just splitting it up using atom optimizer, sparse categorical cross entropy, and yeah, that's pretty much it. So yeah, as we're using a pre-trained model, it's pretty easy to use. So that's all for today's video, so thank you for watching, and I'll see you in the next video. Goodbye.